Good morning. Today I'm going to give you a crash course in graphing in standard form. Just as a reminder, standard form looks like ax squared plus bx plus c. And a tells us the same things about the graph as it does in this form, vertex form, which is why we choose to use the same variable to represent that position of the function. So it is a vertical stretch factor. However, B and C tell us different things than H and K tell us, so that will not be our vertex. In order to find our vertex in standard form, we use the axis of symmetry. So I'm going to leave vertex there. The axis of symmetry, I'll actually write that down in case you don't know what that looks like, is the vertical line that passes through the vertex, essentially cutting the parabola in half. So the axis of symmetry is equal to negative b over 2a. That comes from the quadratic formula, and maybe later this year I'll show you exactly where that comes from. But for now, just know that the axis of symmetry is equal to negative b over 2a. It is a line, so it should be written as a line, which would be either x equals or y equals. Since it's a vertical line, it's x equals, so it's x equals negative b over 2a. So negative b over 2a is the x of your vertex, and then you need to plug that in order to find the y value. And then from there, you have a couple of different options on how to find points. And the one thing I will tell you, one point that is easy to find from this form is the y-intercept. And the reason why is we know every point on the y-axis is 0, some number. Well, if I plug in, and I'm even going to do it to this form, ax squared plus bx plus c, no matter what, those will become 0. So my y-intercept is always going to be c. All right, so let's take a look at a function. I have f of x equals negative 2x squared plus 8x minus 5. And the first thing I always find is the axis of symmetry, so I can find the vertex. So we have A, B, and C. Watch your signs. Make sure you take the sign with the value of A, B, or C. So in this case, x is equal to the opposite of b over 2a. Negative 8 divided by negative 4 is 2. So then my vertex is 2. And to find any y value, if you know the x value, just plug in the y value. So we have negative 2. So this is f of 2. Negative 2 times 2 squared plus 8 times 2 minus 5. So that's negative 8 plus 16 minus 5. And I believe that's negative 3. So that would be 8 minus, oh, no, it's positive 3. Look at that. This is the first math problem I've done today. It's about 6:45 in the morning. I think I'm still waking up. All right. So we have the vertex at 2, 3. Now, because a is negative, just like in vertex form, we know this function is going to open down. And you have a couple of options about how you get more points. The first option is a table. The table works every single time. I would recommend maybe making sure you're doing your mental math quickly, because I think the table takes a little bit longer. So if this is the method that you're choosing, I would pay attention to how long you are spending finding the y values. Unlike when we're in vertex form, you don't need to create a parent table and the transformation table, because we don't know the transformations for this function. So in order to graph a parabola, we need some points on either side of the vertex so we can get a good picture of it. So in my table, I stick the vertex in the middle, and then I pick some x values below and some x values above, and then plug and chug. So 0, we kind of talked about just a minute ago, that's going to give us our y-intercept. And if you plug 0 in, the x's just become 0, so you're left with negative 5. If I plug in 1, I have negative 2 times 1 squared, which is 1, plus 8 minus 5. Negative 2 plus 8 is 6, minus 5 is 1. And then although these points should be the same because of symmetry that exists within parabolas, I'm still going to plug in the values only to make sure I didn't mess up on the first two values. So it's kind of like you're checking your work as you do that. So negative 18 plus 24 is 6, minus 5 is 1. And then negative 2 times 16 plus 8 times 4, so that's negative 32 plus 32, which is 0, minus 5 is negative 5. So now I'm just going to plot those points. 2, 3, 1, 1, 0, negative 5, 1, 2, 3, 4, 5. 3, 1. And then I'm just going to kind of fill in the symmetry. And I can never make beautiful parabolas on my tablet, but we'll see how smooth of a curve I can do. Yeah, that's pretty close. All right, so that's method 1 that I use for graphing. The second method, I'm just going to kind of start over, but in a different color. I'll use bright blue. So I would still have done all of the work to get the vertex. So method 2 is going to be in blue. I would have done all of the same work to get the vertex. And then I would plot the vertex. And then I would use the vertical stretch factor to get more points, just like I do when I'm in transformation form if I don't use tables. So because A is negative, I know it opens down. So if I go 1 away from the vertex, then I'm going to go down 1 squared times the stretch factor. So down 1 times 2 would put me here. If I go left, I'd go down 1 times 2. If I go over 2, I should go down 2 squared, which is 4. But if I stretch that distance by a factor of 2, I would go down 8, which would put me here. And I would do the same thing when I go left 2, down 8. And I get those same 5 points I got by plugging and chugging, but I got them much faster. And if this isn't how you want to graph, I'm not making you graph this way. It's just a quicker way that you can learn to kind of help it go faster. Please email if you have more questions. Have a great day.